Hello and welcome to the channel. Today we'll be asking, is there such a thing as too much sunshine for our solar panels? When I was doing online review research for solar blankets, one of the common themes I came across was that users of these blankets said that the output dropped off considerably faster over time than they would expect. In this video I'm going to demonstrate a probable cause for this and what we can do as users to mitigate this. I'm here in Queensland, typical summer's day, 35 degrees, so that'll be the testing conditions. We'll be using a radiance light meter. It measures sunlight on the surface in milliwatts per square meter. A functioning panel output should be directly proportional to the light that's falling on the surface times the efficiency factor. So at 100% irradiance, the panel should be outputting 100% times its efficiency factor, etc. So at 80% irradiance, the panel output would be 80% times its efficiency factor. But the manufacturer's specifications will tell us what the short circuit current is. I'll be doing short circuit current tests with the irradiance meter using a DC clamp meter, and along the way we're going to be looking at temperatures using a spot heat gun and a small thermal cam that attaches to the bottom of my iPhone. So stick with me to the end, you may learn something interesting.
First up is the Hardkorr blanket, been operational for about 5 minutes. Temps are the same as ambient, or very close. 100% irradiance, 12.5 amps. Output is right where it should be. After only 15 minutes, temperature has increased dramatically. Still 100% irradiance, but we've lost about 1 amp of output. If you're in the planning stage of your off-grid build, one of the hardest parts is coordinating the components and reducing the risk of over-engineering or undersizing your system. I've made this super easy for you. Check out my Solar Sizer Pro at themusingmoose.com. Simply punch in your daily energy use, your peak power usage, your location, your preferred system voltage, battery type, panel wattage, and days of autonomy required. It will then help you determine the size of your solar array required, your battery bank capacities, inverter, charge controller, and fuse breaker sizings. On the next page, add the system voltage from your previous page, your expected current, which will be the breaking current of your protection, and the length of your cable runs. This will then give you your cable size required and the allowable voltage drops. If you find this useful, let me know in the comments. Now back to the video. Next up, it's the turn of the Itech World hard panel. Temperatures are very close to ambient. It's been running in short circuit current conditions for about 5 minutes. Our light meter is telling us we have 100% irradiance, though my shadow does block the light meter a little bit just here. It picks up again. Amps are right where they should be within specifications, around 8.9. "15 minutes later, still 100% irradiance, but temperatures have picked up dramatically. Output has dropped off somewhat, but not much. That will be due to heat in the panel. 100% irradiance. Remember, heat creates resistance. Resistance is a load. That's where a little bit of our output will be going. Next up, we have the Itech World blanket running at ambient temperature. Amps are right where they should be. 15 minutes later, look at those temps. The blanket is a little bit stressed, starting to show hot spot. Amps have dropped off ever so slightly due to the heat.
So as you saw with those little tests, it's easy to get up to temperatures approaching the upper limits of the warranty in a very short time, particularly with the blankets which showed emerging hot spots. The temps on the hard panel were more even. Although it got to 70 degrees, the output didn't change. The Hardkorr blanket got to 90 degrees and the ambient temperature was only 35 degrees. We even saw the Hardkorr drop off an amp. Quality blankets like these have bypass diodes designed to bypass any excessive hotspots, and that was what likely happened in the Hardkorr blanket as output reduced as it went into protection mode. If we continue to operate our panels in temperature ranges beyond the warranted limits, we will degrade our gear faster and void warranties, which I suspect many of us are doing. Long-term overtemps will cause the chemical bonds within the cells to separate. So what can we do? Airflow is obvious. It's important to get air underneath our solar. This is easy on the Itech blanket, not so with the Hardkorr. By design, it's difficult to elevate. We can disconnect our solar in the middle of the day, but this may not always be viable. We can be more proactive with chasing the angle of the sun earlier and later in the day when temps are cooler. At the very least, we should be monitoring our temps. Thermal cams are great for this, as well as checking battery bank cables and joints. I'll leave a link in the description to the camera that I use. I hope to try a cooling accessory in a later video. Keep a lookout for this. If you found this helpful, please like and subscribe. Thanks for watching.